Hi guys, we're looking at an idea called completing the square today. We'll be looking at text and tests for page 69. I'm going to start off with just an example that's not in the book, which is just this. If you're asked to expand x plus 3 squared, well, squared means multiply by itself, so you might say x plus 3 by x plus 3. You get x times x plus 3 plus 3 times x plus 3. X squared plus 3x plus 3x plus 9, x squared plus 6x plus 9. And we've seen that kind of calculation before. In class, I usually tell you to square the first, square the second, and then twice the product here. 3 multiplied by x and multiplied by 2 gets you the middle term. So square the first, square the second, twice the product. If you prefer the array method, there it is there. Square the first, square the second, and there's the product coming up twice. So I'm just going to do this one here. 2x plus 3 squared. Well, square the first, you're going to get yourself 4x squared. Square the second, it's going to be plus 9. And twice the product here is minus 6x multiplied by 2 is minus 12x. Okay, and more traditionally, you'll write it in that order, but it's the same thing. You might just pause the video and give that one a go yourself there, please. 5x minus 4 squared. And you'll see me do it now in a second. Okay, so to square the first, you're going to get 25x squared. Square the second is plus 16. And twice the product here is minus 20x multiplied by 2, which will be minus 40x. Again, you'll normally see it written more in this order. Now, if we are familiar enough with that, when we're asked to get something kind of in this form and to work backwards to this, we can do that. If we can recognize that it's a completed square. Now, a completed square is something, or a perfect square, something that can be written as just a whole number squared. So question 1 asks us to find the value of c that completes the square in each of the following. So if this is a perfect square, what value does c have? How do we complete the square here? Well, that's the first squared. This has to be the second squared, which makes this twice the product. Okay, well, half the product then is 14. So this is going to be a plus 14 squared. So there's square the first. So c then, twice the product, has to be 196. Which is 14 squared. C is the second squared. So square the first, square the second, and then twice the product, 14 multiplied by a multiplied by 2 got me the 28. Okay, now you can reason it out like that, or you can take a little shortcut, which is to say, well, this number is always, in a completed square, it's half of this squared. Okay, so that's 14 squared, 196. So in question 2, you're asked to complete the square in each of the following. Now question 3. Write each of the following in the form x squared minus p squared plus q. So this is called completed square form, where you have a square part plus some other constant. Okay, and this can be a useful way to write a quadratic equation. So that's what we're going to learn to do today. So x squared plus 4x minus 6 is not a perfect square. You can't write that in this form here, something just squared. What you can do is say, well, if I move that minus 6 over here, I'd say, well, if I wanted a perfect square, I'd want half of this number squared. Okay, so 4 over 2 squared, which is going to be 4 itself. So if I put a plus 4 in there, then I'll have a completed square. But you can't just add in a plus 4, okay? You do a plus 4 and a minus 4, that counts as adding nothing. But now I have it in a form where this bit here is a completed square, and this is minus 10. Okay, minus 4 take away 6 is minus 10. So this bit here is, there's the first squared, there's the second squared, so that has to be 2 squared. Okay, and then twice the product, 2 by x by 2 got me the 4x. So that's the underlined part, and then take away 10. And that is this quadratic written in completed square form. Now, one of the reasons that can be useful, just over here, I've actually found the roots to the same quadratic, and they're 1.16. This is the roots to this quadratic here. 1.16 and minus 5.16. So I sketched it out here. And the reason I've done this is because I wanted to be able to point something out to you. The value of this part here has to be positive. It's a square number. The smallest value it can take is 0. Now, when does that happen? Well, that happens when this number here is -2. So at -2, this whole function will have a value of 0. Take away 10 is -10. So this point down here, that's -10, and that's -2. So -2, 10 is the minimum point. Now, up to now, we haven't had a good way of finding a minimum point. We'll see other ways later in the course, but this is one way to do it, which is by completing the square here. So that finds the minimum point of a quadratic. It's always going to be minus whatever this number is, and then whatever this number is for the y coordinate. Okay, so think about this. This is a function y equals all of this. This is how they should be written, y equals. Confusingly, the book has 0 equals. That's a misprint. Y equals all of this. Well, then the smallest value y can take is when this bit is as small as possible, which is 0. So that is, -10, excuse me. That's our minimum point. And that happens when x is, well, this will be 0. If you want this to equal 0, you might say something like, well, x plus 2 has to equal 0, so x has to be -2. Okay, but either way, this completed square form is a way of finding the minimum point. So let's just do 3 part 2, write each of the following in that form. Okay, we're not gonna, they're not asking us for a minimum point yet, but they want us to write this in completed square form. So again, you're gonna say, well, half of this number, 9/2 squared. Now you could say 4.5 squared and go to your calculator. You're better off leaving it as a fraction and squaring that as 81/4. Okay, so this becomes x squared plus 9x plus the bit we want, 81/4, minus that, because you can't just add nothing, plus 4. Okay, now I'm going to just box that bit off. That is x, this bit here, well, this is our completed square, these 4 terms. Square the first, x squared. This is the second squared, and you have it over here. It's 9/2. And when you square it, you get 81/4. And then twice the product, well, multiply that by x, you get 9x/2, and multiply by 2, you get 9x. Okay, and that's going to be a plus because you have a plus 9x there. So that's that bit squared. And then 4 take away 81/4. I'm actually going to go to my calculator for 4 take away 81/4 is -16 1/4. Okay, or -16.25. Now, they don't ask for minimum point, but if they did, the minimum point would be, that number there is 4.5. So it'd be -4.5. Remember, you take the negative of whatever this number is, and then -16.25. That's the smallest value this thing can take, is 16.25 or -16.25, and that occurs when x has a value of -4.5. Okay, question 4. The graph y equals a x minus p squared plus q has a minimum point at pq. Okay, so then take the negative value of p, you get positive p, and q there. That's just like we've been seeing. By completing the square, find the minimum point in each of the following quadratic equations. Now, finding the minimum point is of less concern than in each of these questions. You've got a 2x squared, a 3x squared, and a 4x squared. And our trick, half of this number here squared, won't work in that circumstance. So we need to just develop it a little bit, okay? So half of the x coefficient is what I should have said there. What we're going to do here is we're going to rewrite this as 3 times x squared minus 2x minus 1. Okay, so that's just the same thing. I factorized the first two terms. I've left the minus 1 outside. And this is what we know how to work with. X squared minus 2x. So we can still complete a square. We can say, well, half of that is minus 2 over 2 squared. That's 1 squared. So that is plus 1 and then minus 1. Okay. Now, what do we get there? Well, we get 3 times x squared minus 2x plus 1. That is x square the first, 1 square the second. Twice the product needs to be negative 2x. I need a minus sign in there. X minus 1 squared. Minus 1. And minus 1 again. So this is this minus 1 here, and then minus 1 again here. Okay, well, let's multiply that out again. Let's multiply out our factor of 3. We get ourselves 3 times x minus 1 squared minus 3 minus 1, or 3 times x minus 1 squared minus 4. Okay, so again, if you wanted to find the minimum point, which is what they asked you for, you'd say, well, this bit here, the smallest value you can take is 0, can never be negative because it's a square. So that means 3 times it has to be 0 as well. So the smallest y value occurs at negative 4. Well, what x value allows that to happen? When x is 1, you get 1 minus 1 here. That whole thing becomes 0. So 1 minus 4 is our minimum point in question 4, part 2. And last question here, I'm going to do question 8, which is on the next page. Now, in question 8, they give you 3 graphs. I'm going to work with f of x here, but you can see there's 2 others, and we'll be doing them in class tomorrow. Write down the coordinates PQ of the minimum points of each of these graphs. So, for example, f has a minimum point at minus 1, 5. G has a minimum point at 2, minus 1. And h has a minimum point at 4, 1. Write the equation of the graph in completed square form and then in expanded form. So we'll see that in just a second. And then by picking a suitable point on each graph other than the minimum point, verify each equation. So I'm just going to do it for f of x. Okay, it has a minimum point at minus 1, 5. Which means when we write it out in completed square form, it's going to be x plus 1 squared. Okay, because when x is minus 1, that bit will be 0. Minus 1 minus 5. Minus 1 minus 5 should have been the minimum point, excuse me. So I need a minus 5 out here. Okay, that's it in completed square form because that has a minimum point at minus 1 for x and minus 5 for y. Okay, and then expanding that out to get the second part of part 2. Well, square the first, square the second, twice the product, minus 5. That gives x squared plus 2x. 1 take away 5 is minus 4. So there it is in expanded form. Okay, in this form here. And by picking a suitable point. Now the point I'm going to go with is the y-intercept is at minus 4. But I could also go maybe this point up here, 1 minus 1. Verify, well, the y-intercept is minus 4 there already. Okay, so verify that you've got the correct point. Yes, you do. Okay, there are multiple quadratic curves that will have this minimum point. Okay, so you can have all of this multiplied by any number. Multiplied by 2, multiplied by 12, multiplied by negative 17. And you will get a curve that has that as a minimum point. So there are multiple curves that have that. So you always need to check at the end, do I need to multiply through by 5 or multiply through by 7 or something like that. Right, I'm going to ask you now to finish questions 1 to 3. And then for classwork on tomorrow, we're going to look at question 4, 5, and 6, 8, 10, 11, and question 12. Okay, see you then. Bye-bye.